With this lesson, we are going to work with equivalent fractions. And our entire goal is just to be able to write and also simplify equivalent fractions. Thus, we need to start by defining equivalent fractions would be 2, although it could be more, 2, 3, 4. But 2 fractions are called equivalent whenever they will have the same decimal format. So if you divided them out, they would both give you the same decimal answer, the same decimal version. We would also call one in simplest form whenever the numerator and the denominator are relatively prime. Remember, relatively prime means that they have a greatest common factor that's equal to 1. That'll only happen when they have nothing else in common. So there's not a common 2 for a factor, there's not a common m for a factor, nothing is in common, everything has already been divided out. Now, as we've been seeing, equivalent fractions are something that you've already done before. You are very familiar already that you could have a fraction like 6 over, or 60 over 100. This can be written in many different ways. We could write it as 6 over 10, because they had that common factor, times 10 times 10. 6 over 10 is equivalent with 60 over 100, because we'd be able to divide out by that common 10 that they have. We also know that it could be written as 3 over 5, because if we take 3 times 2 and 5 times 2, we'd be able to get the 6 over 10. You're very familiar already with equivalent fractions when we use numbers only. Of course, we will do a quick review saying, okay, remember some of these pieces, but then we will also start examining equivalent fractions when we start using variables. Once we start putting monomials and exponents with these, how is it similar? How is it different? Okay, so first thing we need to do are just start looking at some fractions that are equivalent to 6 over 18. And there are going to be lots and lots of correct answers. These are not the only ones. In order to identify or create an equivalent fraction, we can use multiplication or division. For 6 and 18, do they have anything in common? They both have a 2. So one thing we could do is divide both of them out by 2. 6 divided by 2 would give us 3. And 18 divided by 2 would give us 9. That is one equivalent fraction. We'll notice then that that's not the only thing we can do. Well, we use division to create this set of answers for 3 over 9. I would also like to use multiplication. And so we could pick something, and it doesn't really matter which number we choose. But let's say just multiply by 5. And I'm picking 5 just because it's the number that popped into my head. 6 multiplied by 5 would give me 30. 18 multiplied by 5 equals 90. Here is another equivalent fraction. Ultimately, as long as we multiply or divide both the numerator and denominator, the top and the bottom, as long as we multiply or divide by the same thing, we will create an equivalent fraction. And so some other ones that we could have recognized, if we had multiplied by 2, we would have had 12 over 36. if we had divided by 3 instead of dividing by 2, we could have had 2 over 6. All of those are equivalent fractions. We've got 5 different equivalent fractions already, and we were only asked to get 2 of them. Using these specific examples, then, we had 12 over 36, 2 over 6 are equivalent. Or if you wanted to, we could use 3 over 9, 30 over 90. There are lots and lots of correct answers here. And of course, this is the component that you've seen before. You've worked with creating equivalent fractions when they were based on numbers only. So, let's create 2 equivalent fractions. And we're only going to do 2 of these. So, quick show of hands, which one do you want to avoid? Do you want to skip number 1, skip number 2, or skip number 3?
3.
Okay, and the class voted not to do number 3. That's fine. Now, for number 1, do you want to multiply or do you want to divide?
Divide.
Okay, if you're going to divide, they have to have something in common. They both have a 7 in common. So 7 divided by 7, 14 divided by 7, we have 1/2. Of course, that's a technique that you probably remember is simplifying fractions. But we don't have to do dividing. We can also multiply. And if you multiply, you can take anything you want. Pick any number. Go. Okay, so pick 4. 7 times 4 equals 28. 14 times 4 equals 56. And we have created more equivalent fractions. Both of those are correct. Likewise, we can do this with 4 over 16. What do you want to divide by? Okay, I'm seeing people tell me the number 2. If we divide by 2, we get 2 over 8. Absolutely correct. But you also noted that we could also, DJ just told us we could have also divided by 4. It's not like we have to do multiplication to get another one. We could do divide twice, that's okay. And if we had done dividing by 4, we'd get another equivalent fraction, 1/4.
That's like 4.
Now, as we noted, that's a process called simplifying. If we are going to simplify, we have to identify something that they have in common. Now, I am very, very aware that you could look at these 2 numbers and we could identify something that they have in common. For instance, they both have a 4. So we know that we could simplify it down and just divide out by the 4 to get 2 over 9. That is a very quick way. I'm not telling you to do it anything other than there's nothing wrong with doing it this way. In fact, it's an excellent, quick, fast, it's just a great method of doing it. However, I want to show you another way of doing it in preparation for simplifying monomials. So that way, when we start putting variables to these pieces, we can see how they connect. We're going to note that 8 has prime factorization of 2 times 2 times 2. And we will also note that since 36 is 4 times 9, we could get our prime factorization 2 times 2 times 3 times 3. And of course, you could get those by creating our factor tree or anything that way. Based on those, we saw before that we could identify the things that they have in common. They both have a pair of 2's, so our greatest common factor, 2 times 2, is 4. That's why I chose to divide out by the 4 in the beginning, because it's the greatest common factor. I want to emphasize this step here. When we simplified, what we did was divide by the greatest common factor. This is going to be our first tool, our first idea for when we start working with variables and monomials. We're going to take the tool of dividing by the greatest common factor. So just finishing it off, we saw already all the rest of this stuff in red. If we divide out by 4, it becomes 2/9. Okay, so quickly, let's simplify them. And we will skip number 5, just to save us some time. What can we divide out by?
6.
For 3 and 18? They have a 3 in common, so when we divide by 3, we get 1/6. For number 6, what could we divide out by? Well, it's worth noting, their greatest common factor is actually 6. I don't want to divide out by the greatest common factor, though, because right away, DJ, you said, well, they've got a 2 in common, so we could divide that out right away. Not a problem with dividing by any common factor. That would give us 12/21. And now we would recognize that they still have more in common, and so we could divide it out again, which would give us 4/7, and then we're done. It's worth noting that this stuff here in the red took 2 steps, because we divided by any common factor instead of the greatest common factor.
This 4 one of those?
No, 4 won't go into 42. Not evenly, anyway. If you recognize, though, that 6 was the greatest common factor, we could have done this with just 1 step instead of taking 2. Ultimately, we get the same answer, so it doesn't matter if we do it in 1 step or 2 steps. It's just a matter of preference. Do you prefer to do 2 smaller steps or 1 bigger step? Well, that's the idea when we start working with monomials. We still have the same goal of simplifying, but now we've got variables all over the place. And we can do it several different ways. First of all, we're going to start by getting our factorization. 14 equals 2 times 7. X squared we know is x times x. And then we've got a y. All that will be over our denominator. 5 times 7 times x times x times x. Like before, we have to identify the things that they have in common, and we're going to divide them out. Well, what things do they have in common? They do have a common 7, so we are going to divide out by a 7 on the top, divide out by a 7 on the bottom. What else do they have in common? They have a common x. Anything else? A second common x, so we'll divide out by those as well. What we wind up seeing then is all the stuff that they have in common. What we recognize then is that all the stuff that they have in common, top and bottom, wind up canceling each other out. When we divide out by the 7, that's gone. When we divide out by an x, it's gone. When we divide out by the second x, it's gone. All of those pieces that we had, and I'm going to erase some stuff on the top. So before I do, I want to make sure that everybody has stuff written down. Do you have this stuff written down in the blue on top? Okay? Each one of those pieces that they have in common cancel each other out. 7 cancels the 7. X cancels x. X cancels x. And what we're left with, that's our fraction. What's left on top? 2y. What's left in the bottom? That's our simplified fraction. Any factors that they have in common, top and bottom, for the numerator and denominator, the common factors will divide out, leaving behind all the other stuff that they don't have in common. So, let's go through all 3 of these. How would we factor 9a? 9 is equal to 3 times 3, and there we have an a. Then we have 5 times 3 times a times a. Which pieces will divide out? Which pieces cancel? 3's cancel, a's cancel, and so what got left behind? 3 over 5a. We have simplified our fraction of monomials. What about the second one? 16. 2 times 2 times 2 times 2. And I know I'm going through that quickly because you know how to do factor trees, you know how to get the prime factorization. Then we had m times n times n. 2 n's because our exponent was 2. Since 28 is 4 times 7, we wind up with 2 times 2 times 7 times n. What simplifies? Of course, we have a pair of 2's, another pair of 2's, a pair of n's, and what's left? well, 2 times 2 would be 4. M times m is m squared, and then there's a 7 in the denominator. We've simplified our fractional monomials. We're done.
Yeah.
Oh, I'm sorry. I read this incorrectly. I saw this as m times m, and I don't know what my brain was thinking. It's not. That's not 2 m's. It was m and an n. I didn't see it correctly. I don't know what my brain was thinking. Thank you for catching that, Brenda. And getting a start for a couple people. Remember that 39 is equal to 3 times 13. A couple people are having trouble getting started with that part. And after checking your work, we have s t times t, 3 times s times t, and now we can start checking for all the things that will divide out. The 3's divide out, a pair of s's and a pair of t's. Therefore, we're left with 13t over s. And that's it for us. All we needed to do, remember that simplifying and finding equivalent fractions is of course important, but the most valuable skill is here, simplifying the fraction of monomials.